Today we're going to practice solving linear systems, all methods, using the OMGmath method. This graphic is going to help illustrate what sort of answers we could get when we're solving linear systems. If the lines are parallel, there's going to be no solution. If they intersect, there is one solution, and if it is the same line, there's an infinite amount of solutions. The problem we're given first is to find the solution of the two linear equations by graphing. The first thing we observe is that we're given two linear functions. One is in standard form and the other one is in slope-intercept form. Our mission is to graph both of these functions and to find where they intersect. Our game plan is to convert the first equation into slope-intercept form, then graph both equations on the same graph. The first thing we do is take our first equation and we change it into slope-intercept form. To put it into slope-intercept form, that is the form y equals mx plus b, we take our equation, 2x plus y equals 1, and we subtract 2x from both sides. So we get y equals negative 2x plus 1 for this equation, and our other equation is y equals 4x plus 4. To graph these, we are going to use y-intercept and slope. Our y-intercept for our first equation is 1, so that means we start at 1 on the y-axis. Our slope is negative 2. Negative 2 is our rise. We do not have a run, so we put 1 on the bottom because negative 2 over 1 is the same as negative 2, and it helps provide a run for us. Since it is negative, we're going to go down 2 to the right one. We always go to the right. If it's positive, it's up and to the right. If it's negative, it's down and to the right. Then I'm going to go down 2 over 1 again, down 2 over 1, down 2 over 1. Then I'm going to go the opposite direction. I'm going to be very clear with my point since I'm trying to find a place where these two graphs intersect. I want to make sure I have my points drawn perfectly. Then I draw a line through my points and graph my second equation. My second equation I'm going to graph in a different color so that it's easy for me to see where they intersect. For this one I start at 4, so I go up 1, 2, 3, 4. And then my slope is 4. Again, I don't have a run, so I'm going to put 1 as my run because 4 and 4 over 1 are equal to the same thing. So then I'm going to go up 4, 1, 2, 3, 4, over 1. Then I'm going to go down 1, 2, 3, 4, left 1. Now that I have my points plotted, for my next line I'm going to use a graphing tool so that I can get a really clear picture of what the line that goes through these points is going to look like. So I'm going to use my line and draw a line through these points, making sure to line it up as best as I can with the points that I am given. Once I line it up, I can see that the point of intersection between my two lines happens right here. The x value at this point is negative 1/2 and the y value is positive 2. So my point of intersection for this function, my x value is going to be negative 1/2. My y value is positive 2. So I have found the point where my graph intersects. The next directions say to find the solution to the system by substitution. We're going to get the same answer, but the method for getting there is going to be different. Again, we observe that we have two functions, one in standard, one in slope-intercept form. We're still going to find an xy coordinate that makes both equations true. And then to do this, we're going to follow this system right here. Create one equation with one variable from the two equations. Once we find that variable, we can plug it in and solve for the other one. Here's how we do it. In this scenario, we are lucky because one of our variables is already isolated. If it is not isolated, we would have to take either x or y and solve for it. In this case, y is already alone, so I'm going to take my first equation, 2x plus y equals 1, and instead of putting a y there, I'm going to put what y is equal to. So I'm going to substitute in 4x plus 4 and set this equal to 1. Then I'm going to go through and simplify. 2x plus 4x is 6x. Plus 4 equals 1. I subtract 4 from both sides. 6x equals negative 3. Divide 6 on both sides, and I get x equals negative 3/6, which reduces to negative 1/2. I know this is correct because I just got this same answer when I was graphing. Now that I know x, I'm going to take x and plug it back into one of these equations. This one looks easier since y is by itself, and that's the one I need to find. So I have y equals 4. Instead of x, I'm going to put negative 1/2 plus 4. Half of 4 is 2, and since this is negative, a negative times a positive is going to be negative. So 4 times negative 1/2 is negative 2 plus 4. Y is going to equal negative 2 plus 4, which equals 2. And then remember, when we write our answers for solving, we write them as a coordinate pair x, y. So our answer is negative 1/2, negative 1/2, 2. And we again know this is correct because we already found this answer when we graphed. The last way to solve a system is by elimination. The steps for elimination are the same as for substitution and graphing. The difference is in how we solve it. For elimination, in order to eliminate, we're still trying to create one equation from the two given. So we're going to take 2x plus y equals 1. In order to eliminate, we have to get one of our variables to cancel out, and we have to make sure both of our equations are in the same form. So we are in standard form here. We have x, y equals a number, but we are not here. So we need to take y equals 4x plus 4 and get it in the same form, which means we're going to have to subtract 4x from both sides. So we're going to get negative 4x plus y equals 4 as our other equation. To do elimination, we need to be able to add these two equations and have one of our variables cancel out. To cancel out, they have to have the same value but opposite signs. Right now, our x's can't cancel out because we have a 2 and a 4, and our y's can't cancel out because they're both positive. So you have an option. You could multiply the top by negative 2 and cancel out x's, or you could multiply the top by negative 1 and cancel out y's. I'm going to multiply by negative 1 since it's simpler. So that's going to give me a new equation that I'm going to write on the bottom. I'm going to write it in pink. So it's going to be negative 2x minus y equals negative 1. Make sure you distribute this to every single term, including the one after the equal sign. So this equation has been changed into the new pink equation, and I take these two equations and add them together. Negative 4x and negative 2x makes negative 6x. Positive y and negative y when added cancel, which was my goal, and this is equal to 3. I divide both sides by negative 6, and x reduces to negative 1/2. Now that I have x, I take x and I plug it back into either one of these equations. I'm going to plug it into the second one again because it has y isolated. So y equals 4 times negative 1/2 plus 4. We know that that's y equals negative 2 plus 4, which simplifies to be 2. So my solution is negative 1/2, 2. We solved it all three methods, and we got the same answer doing it all three methods. Thank you guys so much for watching my videos. If you want to get better at math, subscribe to my videos here. If you want more information on math, click on my website link here.